All right, so we finished parasympathetic division, and now we're going to look at the sympathetic division. And I'll just leave my video up here because like you don't need to look at the other side of the screen, hopefully as much. Okay. So what we're going to see is in the parasympathetic division, right, where we have increased activity in some of our organs, we have a decrease in activity in other organs. We're also going to see that there's a slight difference in terms of the anatomy of our two neuron system here for parasympathetic. So what we're going to see is that one, we're going to position our ganglion. Okay, so our ganglion are going to be in the thoracolumbar area. So it's going to be really close to the vertebral column. And I'm going to make my ganglion a little bit bigger than they would be, just so you can see them a little bit better right there. And then what I'm going to do is also additionally over here, maybe about right here, I'm going to draw the aorta. Okay, so the aorta is actually going to be much closer to the vertebral column than it is to the organ, but then I'm thinking about dissections. It's actually quite close to the organ too. I mean, those organs are there. Stuff is literally on top of each other. But the reason I'm going to draw my aorta is because I'm going to put 1, 2, 3 ganglion on top of my aorta. Okay. And then I'm going to label them when I get to foregut, midgut, and hindgut stuff, essentially. So the first thing I'm going to do is I'm going to figure out, okay, so since my ganglion is really close to my spinal cord, that's going to mean that in my thoracolumbar area, I'm going to have my cell bodies that are coming out of my lateral gray horn here and going to my ganglion like that. This ends up meaning these are shorter because they don't have to go as far in the beginning to get to their ganglion. So these ganglion are going to actually be connected together in a line like this. This is called the sympathetic trunk. And so here I have a sympathetic trunk ganglion or a sympathetic ganglion. Like that. So we're going to see that then we're going to have a long postganglionic neuron that's going to come out of our ganglion and it's going to hit our effectors just like this. So see how we go from short to long because we have to go through the sympathetic trunk. Okay. And now I'm going to show you what's going to happen to foregut, midgut, hindgut stuff because you will have to know the specific nerves that innervate foregut, midgut, and hindgut. So I'm going to see that my nerves that are coming off the thoracolumbar regions right here are going to bypass the sympathetic trunk, and instead they're going to hit a specific named ganglion that's going to be on top of the aorta. These nerves are going to have specific names. So we're going to use levels T5 to T9, right, like that. And this is going to be the greater splanchnic nerve. Sorry, I'm writing that so small, but I want to have some room to write my other stuff also. Ugh, sorry, message right in the middle of this video. Okay, so my greater splanchnic nerve is going to hit my celiac ganglion. Okay. Then I'm going to have my postganglionic neuron that is going to be a little bit longer, and that's going to hit my foregut structures. So T5 to T9, greater splanchnic nerve, celiac ganglion, foregut. Then I'm going to see that I'm going to have, again, another nerve that's going to come out like this. And this is going to be from levels T10 to T11. This nerve is called the lesser splanchnic nerve. okay, it's going to hit the superior mesenteric ganglion. Whoops, ganglion. And then we're going to have our postganglionic neuron, which is in green, right? Postganglionic neuron is going to come over here to our midgut structures, just like that. Now, the hindgut stuff is a little more complicated because what's going to happen is part of T10, whoops, I have the wrong color right here. So part of the lesser splanchnic nerve, so the lesser splanchnic nerve can come down to this ganglion, but then we have the least splanchnic nerve, and then we'll also potentially have the lumbar splanchnic nerve right there. All three of these nerves are going to synapse at the inferior mesenteric ganglion. And then they send their message out, their postganglionic neuron, to hindgut. So I'm just going to write these levels in here, and I'm going to write them in black so it's a little easier to see. So this is T10 to T11, lesser. And I'm just going to put SP, splank, because I don't have enough room right there. And then this is going to be T12. This is going to be the lesser. This is the least splanchnic nerve. And then the last one goes from L1 to L2, and this is the lumbar splanchnic nerve. Just like that. So we see levels T10 to 11, T12, L1, L2 go to the inferior mesenteric ganglion and then go to hindgut. So that means lesser, least, and lumbar nerves can potentially innervate the structures that are associated with the hindgut. And there actually are not that many structures associated with hindgut, but what's not here is that the bladder is actually derived from hindgut. So the lumbar splanchnic nerves actually innervate portions of the bladder, and that's why this is the lumbar splanchnic nerve also, because it's a little bit lower. And I think parts of the rectum are also innervated by the lumbar splanchnic nerves, but I would have to double check that. Okay. So hopefully this picture helps you a little bit. Sorry, it's a little bit muddled right in this area. I should have moved my aorta over a little bit. Think about moving your aorta over a little bit. You probably have a little bit more room to draw that. So now hopefully you have a nice review of what's happening in the spinal cord. You understand we have to have two visceral motor neurons and a ganglion to send to the central nervous system, from the central nervous system to our effectors. Let me explain that one more time, why this has to happen. Do you see now we have multiple effectors? They're all getting a message. That message, though, is going to be different. Their message is the same, but their message is going to cause different effects. So it's not like a skeletal muscle, and I'm just going to say contract. Here, I'm either going to say you need to contract or you don't need to contract, right? So that's why the message becomes more complicated, essentially. Hopefully you can see here with the excuse me, the sympathetic portion, like imagine this message coming out, it's going to go to our sympathetic trunk, and then it's just going to fly out to basically all of our different organs simultaneously. Okay. And this is the reason why you have to have the sympathetic trunk in order to do that. You don't have a parasympathetic trunk because you're primarily using a single nerve to innervate, like, I don't know, 80% of the stuff in your torso. And I actually remembered, I can't actually erase that. What I should have done is I actually should have put my vagus nerve all like that. So amend your picture. The vagus nerve should actually go over the portions that innervate the heart and the lungs as well. Okay. That'll come back in 2240. It's a little less important, but I just wanted to make sure that that's more accurate. So hopefully you see that parasympathetic and sympathetic have dual innervation. They innervate the same exact effectors, but they have opposite effects, right? And they have different anatomical features. So we see parasympathetic is going to be a long preganglionic neuron to a ganglion to a short postganglionic neuron. And then we see in sympathetic, we have a short preganglionic neuron to a ganglion to a long postganglionic neuron. All right, so hopefully that helped you with all the stuff for autonomic nervous system.